In this video, I want to show you how to find the critical points of a function, if any exist. The first step is to start by taking the first derivative of the function. In this case, the function we were given was 4x squared minus 3x minus 1. So the first derivative of that function is 8x minus 3. And then next, ask yourself, are there any values for x that would make this first derivative fail to exist? And by that, we simply mean, would the first derivative be undefined if you plugged in a particular value for x? Well, in this case, no. 8x minus 3 is a linear equation, and all values for x are in its domain. So there aren't any values that would make the first derivative fail to exist. The next step is to take that first derivative, set it equal to 0, and solve for x. 8x minus 3 set equal to 0, solving for x, gives you an x value of positive 3 over 8. So this function has only one critical point. Here's another function where we're asked to find the critical points, if there are any. And this time we have a rational function. F of x is equal to, the numerator is 4x, and in the denominator x squared plus 16. Well, the first step is to take the first derivative of the function. We're going to need the quotient rule to find the derivative of this rational function. And when we do that, the first derivative is equal to negative 4x squared plus 64 in the numerator, and the quantity x squared plus 16 squared in the denominator. Well, next we ask ourselves, are there any values for x that would make this first derivative fail to exist? That is there any way for this denominator in the derivative function to be equal to a 0? Because if we divide by 0, then the first derivative would fail to exist. Well, it turns out the answer to that is no. You can think of any number you want to plug into x. Once you square that number and add 16, and then square that sum, you get a positive value. So there's no value for x that would make this first derivative undefined or fail to exist. So our next step, n, is to take the first derivative and set it equal to 0. And when I do that, the only way for the first derivative to be equal to 0 is if the numerator is equal to 0. That's the only way that the first derivative is going to be equal to 0. So I'm just going to look and concentrate only on the numerator and set that equal to 0. Again, if the denominator becomes 0, well then we have an undefined value, and that's where the first derivative would fail to exist. But we just said a moment ago that there are no values for x that would make this undefined. So I'm only going to concentrate in the numerator. When we set the numerator equal to 0, negative 4x squared plus 64 equal to 0, and solve for x, well, I would subtract 64 from both sides, divide both sides by negative 4, and we get x squared is equal to a positive 16. To find the value of x, we simply square root both sides of the equation, and so this original function has two critical points, at x equals positive 4 and at x equals negative 4. Here's one last example where we're asked to find the critical points of the following function, if there are any. And the function that we're given is 2 root x minus x. And that minus x is not underneath the root. It's only 2 square root of x, and then outside of that square root is a minus x. But this time there's a little twist. We're not looking at the entire domain of this function. We're only looking at a closed interval between 0 and 4, including 0 and including 4. Those are our endpoints. And so critical points, remember, they do not exist on the endpoints. They must exist in the interior of a given interval. So the first thing we're going to do is we're going to take the first derivative of this function, which gives us 1 over radical x, and that quantity has a minus 1 outside of it. So 1 over root x minus 1 is our first derivative. And when we ask ourselves that that first question, are there any values for x that would make this first derivative fail to exist? This time, yes. If x is equal to 0, then our first derivative would fail to exist. Keep this in mind, all right? If our first derivative is equal to 0, if x is equal to 0, then our first derivative would fail to exist. However, and this is important, remember that critical points do not exist on the endpoints. And since the only value that would make this first derivative fail to exist, which is 0, happens to be an endpoint, then we're not going to consider it a critical point. So we can erase that, we can forget about that. There are no values in the interior of our given interval, our given closed interval between 0 and 4, that would make this first derivative fail to exist. So we're going to move on, and we're going to set the first derivative equal to 0 and solve. When we do that, we could do all kinds of algebra tricks here. It's totally up to you which method you want to go. What I suggest you do is I suggest that you add 1 to both sides of the equation. That becomes a positive 1 on the right-hand side. This minus 1 becomes a positive 1 on this right-hand side. And then you could multiply both sides by root x. When you do that, you get the square root of x is equal to 1. To get rid of the square, we to get rid of the square root, we square both sides of the equation. And this just leaves us with x is equal to 1. Since x is equal to 1 is a value in the interior of our given interval, then this is the only critical point that we're going to consider. Right? The only one that is in the interior of this closed interval is x is equal to 1.